Hi, this is a problem from one-dimensional motion. The problem is like this. A ball is dropped from the top of a tower of height 78.4 meters. Let's talk about only that part of the problem. Say this is the tower. From the top of the tower, a ball is dropped. Dropped means initial velocity is 0. Its acceleration is acceleration due to gravity plus z, that is 9.8 meter per second square. It is falling from a height of, as it is given, 78.4 meters. We can use a simple equation S equal to ut plus half at square. That's the equation of motion. Here S is h. U is 0 because it's a freely falling body. 0 into t. A is plus g t square. So the equation that comes out as half gt square. So h equal to half gt square is the equation for the first case of the problem, and you substitute the data. H value is 78.4. Half g is 9.8 and t square. This is 4.9. So t square is 78.4 by 4.9. So that is, well, if you calculate this value, it comes as t square is 16. T will be root of 16, that is plus 4 seconds is the possible value. Negative values we don't take. So the first case, it takes a time of 4 seconds to reach the ground. And simultaneously what happened is, another ball is thrown down with a certain velocity 2 seconds later, but both the balls reach the ground simultaneously. So the second ball, the second one, thrown down 2 seconds late, but both reach ground simultaneously. Both reached at a time. Means what? It is thrown with a velocity, obviously it takes less time. It was 2 seconds late. As if you draw the diagram for the second case, its u is not equal to 0. It is falling the same height of 78.4 meters. It's also coming down. So u equal to plus z, 9.8 meter per second square. And it is 2 seconds late. So it takes total of 4 seconds of the first case minus 2 seconds because it is 2 seconds late to reach the ground, because both of them are reaching the ground simultaneously. The first one has taken 4 seconds. The second one is 2 seconds late but reached the ground simultaneously. That means it shall take only 2 seconds. So for the second stone, it takes only 2 seconds to reach the ground. Again, I can write the same formula, h equal to or s equal to ut plus half at square. S is h. Be careful, u is not 0 here because it is thrown down with a velocity, plus half gt square. H is 78.4. U I don't know. T is 2. Half g is 9.8 and it is square. So 78.4 is equal to 2u plus 9.8 by 2 is 4.9. T is 2 seconds. That is 2 square. 2u 4.9 into 4. So 2u equal to 78.4 minus 4.9 into 4. As I said earlier, 78.4 can be written as 4.9 into 16 as per the calculation here, minus 4.9 into 4. So if you calculate that value, it becomes 4.9 common, 16 minus 4, that is 4.9 into 12, that is going to be how much? Yeah, it's 2u, 4.9 into 12. That implies u will be 4.9 into 12 by 2, that is 4.9 into 6, that is going to be this value. 29.4 meters per second. So the second one is thrown down with a velocity of 29.4 meters per second. Thank you for watching.